Hi, this is Dr. Wooten. In this presentation, I'm going to demonstrate simple linear regression using two apps I'm working on in the development of an interactive statistics experience. The first one is over the theory, so let's run this app. So if the true state of nature is aligned, and what we measure has random error, then we have to make some assumptions before we can estimate the parameters beta naught and beta 1, the slope and the marginal change. The assumptions are that the expected value of the residual errors is 0 and that the variance is constant across the line. If we consider the sum of the square errors, we would like to minimize this. So we can parameterize it by plugging in our equation. Using calculus, we can find the partial derivatives. To minimize this, we'll have to estimate beta naught and beta 1. To find the estimates that minimize the sum of the square errors, we'll set this equal to 0. Substituting in for beta naught hat and beta 1 hat, we'll use b naught and b1, creating a system of equations that can be solved in terms of these parameter estimates. Simplifying the equation, we can solve for it. We can create the following construct. When we define these errors, they create a right triangle which defines the relationship between these errors. Since this is true for all error within the models, we have the sum of the square errors. Using alternative notation for this, we can break this down in terms of percentages, and the sum of the square error for the model divided by the total sum of square errors is what we define as r squared. The percent of the variance within the subject response explained by the model. This app demonstrates data analysis and applied simple linear modeling using tropical storm and hurricanes recorded in the Atlantic Basin between 1995 and 2015. There are hundreds of views of this data. In exploratory data analysis, we used histograms and box plots to verify the values and clean the data. But if we look at the histograms, it also gives us a good idea of the data's distribution. And if we look at box plots, we can detect trends. When modeling the data, there are also subsets we can take, such as by category. So if we just looked at category 1, this will give us different parameter estimates in our model. Or we can just look at super hurricanes. Each of these models gave us different parameter estimates. Therefore, it is important that you take multiple views before deciding on a final model. In modeling, we also want to consider the residuals. We've already discussed that the expected value of the residuals is 0, and we expect the variance to be constant. So we might also want to look at the residuals in more detail. If we consider all storms, we see the residuals are better described by the normal distribution than if we just look at superstorms. We could have also subset this data by year. So in the year 2000, there were not that many storms recorded, but in 2005, we had a very busy season. I also want to point out, this is not the only way we can model this data. One of the new ways of modeling data is something called non-response analysis, which takes these measures to be dependent and maps the codependent relationship between them. Notice the pink line that represents non-response analysis gives a very close estimate to the blue line, which is simple linear regression.